Yep, just like that, I'm back again. But this time I'm back with difference of two cubes. So guys, this is basically a grade 10 concept, but we apply it in grade 11 and grade 12. So learn it, okay? Learn it. Today's video is we're going to talk about difference in sum of two cubes, how to factorize them. I'm going to explain their rule and how to apply it. Okay, so if you can see on the screen, we have two questions, right? Which is 8x cubed plus 27. Imagine if they tell you to factorize it. And the other one is 125x to the exponent 6 all over 64 minus 216 all over y cubed. Imagine if they told you to factorize these two. Guys, don't tell me that that's going to be difficult. I mean, come on, MrSir is here. MrSir is here. So yeah, let's just start. Guys, we can see on the screen we have rule of difference in sum of two cubes, and that rule will be explained and simplified. You know, MrSir. And then I will also apply the rule the best way possible, the easiest way possible. Then kind of vibe, but you know I bring that vibe, man. Anyway, let's just start, guys, before I waste your data or your whatever you use. So let's just look at the rule, right? The rule just under the heading there at the top here, you can see we have a cubed plus or minus b cubed. The rule states that when you have plus or minus, what you're gonna focus on is the bases. You see the base here, the a, and the base here, the b. As long as everything is raised to an exponent of 3 and raised to an exponent of 3, just know that the bases are the ones that you're going to focus on and you take into your factorization. So now let's move to the factorization, okay? Into the factorization, we have a here and we have b here. You see, we took only the bases. So you take the first base, you put it here. Then you take the second base, you put it here, right? So you're going to have a plus or minus b. So guys, let's focus on the signs. Imagine in your question you had a plus, which means in your first bracket, you're going to have a plus. But then if you had a minus, in your first bracket, you're going to have the minus. All right. And it works with the opposite now. In your second bracket, let's look at the second bracket here. In the second bracket, the middle term will take the sign that is opposite to the sign you took in the first bracket. So pay attention, guys. You see here in the first bracket, the plus will be opposite to the, look in the second bracket, will be opposite to the sign next to AB. That's the rule, okay? So in your first bracket, you're going to take the sign that is given in the question. But in the second bracket, the middle term will take the sign that is opposite to the sign you took in the first bracket. That's how the rule works, okay? Now we're going to take the first term. The first term in the first bracket, you see here that I'm highlighting, that I'm circling. You take it and you square it in order to get the first term in the second bracket. And then the last term in the first bracket, you're gonna square it and you're gonna say now you have your last term, and the last term is always positive. Okay, now the middle term, remember the sign of the middle term is the opposite to the sign of the sign you took in the first bracket. Now the middle term, this is AB. Basically, you're gonna take the base here, you're gonna take the base that you took here, you multiply with this base without considering the signs. Just take A and you multiply it with B, then you're going to have AB. That's an explanation for the rule. Now let's apply it. Let's look at the first question here, guys. Let's just apply it, okay? The first thing that I'm going to do is I will make sure that my bases, right, are raised to an exponent of 3. So I will find my prime bases. So if you can see, 8 is a perfect cube, right? You're going to say, no, MrSir, let me represent my 8 in a form of a base being raised to an exponent of 3. Okay, so this is what I'm going to do now. I'm just going to say 8, guys, 8 is the same as 2 to an exponent of 3. Right? And I have x to the exponent of 3. Everything should be raised to an exponent of 3, okay? Then I'm going to rewrite my plus. I'm going to say 27 is the same as 3 to an exponent of 3. Now, the first term consists of a constant and a variable being multiplied by each other. The rules of exponents say that when you have the same exponent, I can take that exponent out and the bases will multiply each other. So I'm just going to say 2x basically will be raised to an exponent of 3. Now I have just one base. That's what I'm looking for. So this base here will be my a. Okay? Then I will say plus my 3 raised to an exponent of 3. Do that make sense? So this basically, guys, will be my b. Right? You can look at the rule at the top. You have a cubed plus or minus b cubed. So 2x is like a, 3 is like b. Right? Now I can factorize using the rule. I'll just say, you know what, my first bracket and my second bracket. In my first bracket, remember, you just write the basis, okay? You're going to write a, which is basically 2x, and you're going to write b, which is basically 3. And the sign in the question was plus, which means my first bracket will take plus. I'm just going to write plus, right? Now I forget about the question. I'm only focusing on my first bracket. Okay, then I'm going to say, oh, so I will take my 2x and square it. So which means I will have what? 2x all squared. All right, and the middle term will take the different sign. Remember, in the first bracket I have a plus, which means in the second bracket I will have a minus. Then we'll just say what? Minus what? 2x multiplied by 3, and the last term is always positive. Then I will say 3 squared. I will take the last term and square it. Now the final answer will be, guys, this is just algebra. You're going to rewrite the first bracket and the second bracket. You just, multiply wherever there's multiplication and square where there's a squared. So let's just say we're going to have what? 2x plus 3 into 2, guys, 2 squared is what? Is 4. And x squared is x squared, right? Then I'm going to have minus 2 times 3 is 6. Then I will have x. Then I'm going to have a plus 3 squared is 9. Then I will just say, this is it. I factorized it. We're going to go to the second one on your right. On your right now, someone might say, okay. I can hear you. You're busy saying in your mind that this is difficult. Hey, fraction. Hey. Difference of 2 cubes whenever they are fractions and the exponent is 6 is no longer 3. Hey, when it's big numbers, it's difficult. Come on, guys. Come on. What you think? You have Mr. Sir. So let's just do it together. Let's see how easy this is, guys. So you know what I'm going to do? I'm just going to go like... right, so that we can have more space for this one. All right, so let's do it. The first one, remember, I just said that you make your a just the base and everything else will be raised to an exponent of 3. All I need is a fraction that's going to be my a, right? So 125 when raised to an exponent of 3, if I have to change it to a power with an exponent of 3, it's going to be what? It's going to be 5. So I'm just going to say, oh, Mr. Sir, basically I have 5 to an exponent of 3. I'm sorry for my handwriting, guys. But then remember, they don't mark handwriting. They mark what you wrote. I'm sorry for those who have beautiful handwritings. So now 5 cubed, then x to the exponent of 6. So now, guys, listen attentively. 6, let me write it. You see at the top there, at the corner, I just wrote 6. So yeah, 6 is literally basically 3 multiplied by 2, right? The 2 will be inside, the 3 will be outside. So this is the same, guys, this is the same as what? Me saying x to the exponent of 2 all to the exponent of 3. Because the 2 and the 3, when they're going to multiply each other and they're going to take me back to 6. You see what I mean? So always just change your 6 or your exponent in terms of 3, and the 3 will be out and the other factor will be inside the brackets. That's the system, right? Then I'm going to say all over what? 64. 64 is the same as what, guys? It's the same as 4 to the exponent 3, right? Then I will say minus what? 216, guys, is the same as 6 to the exponent 3. So I'm just going to write it. I'm going to say 6 to the exponent of 3 all over what? Y to the exponent of 3. Now, guys, you can see every part of this fraction here, every part of this fraction here, every part of it has been raised to an exponent of 3, which means I can take out that exponent of 3 out, and then everything else will be inside brackets. Even here on the second part, the 6 and the y, which are your bases, are going to be inside a bracket, and the 3 will be out, right? So my next step will just have what? We'll have 5x squared all over 4 and all being raised to an exponent of 3 minus 6 over y all to the exponent of 3 based on the laws of exponents. Okay, so now, guys, come on, from here on, basically we have A and we have B, right? So this is your A and this is your B, and all are raised to an exponent of 3. Now A cubed minus B cubed will give us what? We factorize. So I'm just going to move this up a bit so that we can have space. So I'm just going to go like, boo, right? Then I'm going to say now we have what? Now if I factorize, I'm going to say the first step is saying first brackets, right? Then the first part, this A here, right? This A here will be in here. I'm just going to say 5x squared over 4. Remember, I'm taking the same sign that I got from the question, minus, right? Then I'm going to write 6 over y, right? And in the first bracket, guys, this is where it gets interesting. Remember, I forget about the question. Once I'm done with my first bracket, I forget about the question, okay? I'm going to focus on what I have in here, right? So I'm going to say, open bracket, you take this base here, you say what? You say 5x squared over 4, then you square it, right? Remember, in the first bracket, you're going to have a squared, so you're squaring a. Then you're going to say, remember, if we have a plus here, a minus here, in the middle term, we're going to have a plus, right? Then I'm going to multiply them. I'm going to say 5x squared over 4 multiplied by 6 over y. Then the last term is obviously a plus, right? Then the last term will be 6 over y all squared, right? Then I'm going to go down, 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 down. Right, the last answer will just have what? We'll just have, okay, Mr. So let's write it clearly. It's going to be 5x squared over 4 minus 6 over y, close, open, right? Then I'm going to have 5 squared, which is 25. X squared, all squared, it's going to give me x to the exponent 4 all over. 4 squared, it's going to give me 16. Then I have a plus. Now 5x squared times 6, it's going to give me what? 6 times 5 is 30. Then I'm going to have 30x squared all over 4 times y is 4y. You can simplify it in the next term. It's up to you. Then the last term will be positive, right? 6 squared will give me 36 all over. Y squared will give me y squared. Then I close. And this is it, guys. You can either simplify it or leave it like that. It depends on what the question is. But then the only term that requires simplification is this here. Is this here. Because 30 and 4 have a common factor, which is what? Which is 2. So, guys, don't tell me this is difficult. Come on, guys. You know what I'm going to do? If I were you, you know what I was going to do? I was going to pause the video right now and just go like, pause, right? Then I would rewrite the whole thing and try it on my own. And when I get stuck, I go back and I replay the video and guys, I am out.